Welcome to Bison Jam, the podcast that covers wide-ranging topics from Yellowstone National Park and the Greater Yellowstone ecosystem. I'm your host, Hugo Sindelar, an assistant professor of film at Montana State University. Today we're continuing our series about the devastating flood that affected the park and its surrounding gateway communities in June 2022. In this episode, we're going to explore the hydrology of the flood. I am joined today by Dr. Cathy Whitlock, Regents Professor Emerita in the Department of Earth Sciences at Montana State University. With Dr. Whitlock, we are going to learn about the weather pattern and hydrology that led to the June 2022 flood. Welcome to Bison Jam, Dr. Whitlock.
Thanks, Hugo. I'm glad to be here.
So let's just start a little bit with you. What do you do and how long have you been working in and around Yellowstone?
I'm a paleoecologist who studies how past climate change has affected the development of ecosystems. So how do ecosystems arise, say, from the last ice age, and how important has climate been in shaping the way they look? So I use the past very much to understand the way the present landscape has developed.
And so how long have you been working around Yellowstone? When was your first research project in the park?
You know, I've been working in the park for over 40 years, I think now. I started as a graduate student in the late 70s. And one project has led to another, and I've looked at different periods of time in the past. And now I'm fully focused on what's happened since the last ice age. So I've worked in the park for a long time on different projects.
What drew you to the park? What brought you to this area initially? What inspired you to do all this research in and around Greater Yellowstone?
Well, Yellowstone's always been an important part of my growing up and my life. My family used to come here as we drive across the country. I grew up in upstate New York, and every summer we'd drive across the country to see grandparents in Oregon, and stopping in Yellowstone was always the major highlight of that trip. So just Yellowstone's always been someplace really special for me. And then when I went to graduate school, I realized you don't just have to be a tourist. You can actually study Yellowstone, and you can go places that other people can't go, and you can answer some of your own curiosity questions about how Yellowstone, why it looks the way it does. So it was kind of a personal evolution, I guess, starting from being a real small child to being a professor.
And I thought before we jumped into the flood, it might be fun for you to share kind of what's one of your favorite memories from working in the park?
Well, I think the fires in 1988 were a major pivotal point for me and my research, because up to that point I was really using lake sediment records and the pollen contained in that mud to reconstruct the vegetation history and tie that vegetation history to climate. And I hadn't really thought about fires. I hadn't really seen fires or experienced fires, and I hadn't really thought about fires. And I remember that year of 1988, I had my first research grant, and I was really determined that I was going to get to all these lakes that I said I was going to get to in this grant. And I was having trouble because roads were closed. But then by the end of the summer, I really realized I was missing an opportunity, that I really hadn't recognized how important fires were in shaping the vegetation. And in fact, they're a factor that helps vegetation change as the climate is changing. So to me, that was really a transformational moment. And then since then, my students and I, we're always considering fire history as part of the story of how the ecosystem looks.
Yeah, so let's switch from fire to water and start talking a little bit about the flood. So fire is a big part of the ecosystem and comes up a lot. What about flooding? Was it something that's kind of on your radar as a scientist that's a part of the park? Is it less prevalent than wildfire? I'm just kind of curious where it sits in the different processes that shape the landscape.
It's really clear that we've had major floods and landslides in the past in Yellowstone. Sometimes they're the cause of a lake. Why a lake is formed is because of a landslide, for example, or the way the flood has changed the course of a river. So you're always thinking of that as one of the factors that's shaping this dynamic landscape. But it's not something in my own research that I'm actually studying flood dynamics. But I recognize how important they are. And we've had floods throughout geologic history in Yellowstone.
All right. Well, now let's talk about the June 2022 flood. I think it would be a good thing to start broad and kind of discuss historical weather and precipitation patterns in Yellowstone National Park in that winter to spring transition. So normally, how does the winter to spring transition go in terms of snowmelt and water availability?
Well, most of our precipitation falls over the winter months, although the highest precipitation, I have to think about how I'm going to say this. The highest precipitation in Yellowstone is actually in April and May, but our snowpack has traditionally come in winter, starts, in the fall and goes through the spring. And that snowpack is really essential for the conditions the following summer. So you want the snowpack to be high and you want it to melt slowly because that's a reservoir of water that nourishes and sustains the ecosystem downstream. What we're seeing now is that we're getting less precipitation than we have historically in the winter, and we're getting more precipitation in the spring. And when it comes in the spring, it's wetter precipitation. It's often accompanied by rain on snow events. It melts faster because temperatures are warmer. And then you go into summer being drier.
So let's kind of jump into that weather picture for the June 2022 flood event. What was the state of kind of the snowpack going into that? And then how did that lead to the flood event itself?
Well, 2021 to 2022 started out as a very slow water year, similar to what had happened in the previous year when we were really in drought conditions. But in 2021 to 2022, we didn't get much precipitation in the winter, so we were looking pretty low. But then some storms came in the spring, and so it was a cool, wet spring, and we had a lot of late snowpack in the region. And we had actually brought the overall year up to pretty much normal by the end of the spring because of these big storms. But that snowpack was very wet, and already by May and June, temperatures were above normal, and it was really starting to melt.
And then what happened on top of all that?
Well, then, so that's happening. And then at the same time, we had a big precipitation event, what some people refer to as atmospheric river. So that's a corridor of water coming from the tropical Pacific, the eastern Pacific, that gets fed in a sort of a linear band to the west coast of the U.S. And these atmospheric rivers are common, they happen, and they really provide most of the precipitation for the west coast. But we had an atmospheric river coming from the eastern Pacific that hit the state of Washington on June 10th, and that dumped precipitation on Washington state. And that moisture then got set up as a series of slow-moving storms moving into the Rocky Mountains, so moving towards the east, that were very, very moisture-laden. And when they hit the Beartooths, what you got was rain falling from those systems on this snowpack. So we call that a rain on snow event. And the warm rain just accelerates the melting of the snow. And so you get the rain added to the snow, and it increases the amount of melt that you get and water flowing down the river. So in a 72-hour period, up to 5 inches of rain fell, but add to that the melted snowpack, and in some places it was 9 inches equivalent of rain, of a rain event, of rain that melted off our mountains and came down our streams.
So you have 5 inches of rain falls on 4 inches of snow water equivalent. So you get 9 total. 9 inches of water comes off the mountain.
Yeah, in short order.
Yeah. And 9 inches of water in this ecosystem is a lot of water, right?
Oh, yeah. Yeah, it is. It's it's a lot of water, and when it's coming off that fast, then it's more than the system can hold. So the ground was already really wet because the snow had been melting. Ground was saturated, so there was no place for that water to go but down the stream channels and creating a huge flood.
Yeah, I looked at the numbers before this podcast, and USGS reported the peak as 54,700 cubic feet per second. And the previous peak, I think you looked as well, was 32,000 in 1918. So a cubic foot per second is about 7.5 gallons of water a second. So 7.5 of your grocery store milk jugs. So if you multiply that by 54,700, you get about 410,000-ish gallon-sized milk jugs moving down the river every second.
Yeah, can you imagine that at Corwin Springs, where the stream gauge is that much water coming through in a second? It just blows your mind.
Yeah, the other calculation I did ahead of this podcast that might be fun to share with listeners is there's a measure of acre feet of water. So how much water to put 1 foot of water in terms of depth on something about the size of a football field. So you have something about the size of a football field in area, and then you have 1 foot of water on top of that. And so that number for that whole day was about 108,000. So you'd need 108,000 football fields with 1 foot of water on them.
Yeah, that's a good graphic image.
It was a pretty crazy amount of water.
Yeah.
So you touched on it a little bit, but can you kind of explain rain on snow again for listeners? I think it's something that you as a scientist, and for listeners out there, I used to be in the sciences as well. It's a pretty common term to us, but for people maybe driving around the park listening or listening at home, they may not have heard the term. So can you explain it a little bit more for us?
Yeah, sure. If you think about precipitation falling out of the sky, the form that it takes depends on the temperature of the air, right? So in Bozeman, when it's cold, we get snow, and we get that light, fluffy snow that everybody likes, that cold smoke. When the air temperature is warm, it comes down as rain. And in between is this rain, snow, slush, where it's kind of rain, it's kind of snow, it kind of switches back and forth during the precipitation event. And we get that a lot in the spring, and it's the kind of precipitation that nobody really likes, I think, because it's just so heavy and wet. So a rain on snow event is when you have a warm air precipitation event, so it's coming down as rain, landing on snow that's already has a high water content, and it's melting. And the temperature of the precipitation just accelerates the melting. And so that's why they're so dangerous, is because you not only are getting a lot of precipitation, but you're leading to a melt event that's very, very rapid.
And some of your work dealing with climate change has kind of looked at how the frequency of these events in the past and then how they might change in the future. So can you kind of tell us how the frequency of rain on snow may change moving forward as our climate shifts?
Well, if you go back to 1950, for example, the elevation of regular snow in the Yellowstone ecosystem was about 7,000 feet. So above that, you could pretty much reliably get snow, and below that, you'd get rain snow, or you'd get rain. By the end, but that elevation's been changing, and it's been rising. And so the projections are that by the end of the century, 2100, the elevation of reliable snow is going to be about 10,000 feet.
Wow.
And the rain on snow elevation is going to broaden and also rise, as will the rain elevations that are at lower elevations. So we're losing our snow, we're increasing this wet snow slush elevation, and we're increasing rain at lower elevation. And I should say that's just simply a function of rising temperature, right? It's not anything more complicated than that. It's sort of rising temperature and the impact it has on whether you get rain or snow, how fast the snow melts, how fast you get runoff, and it's temperature driven.
So let's dive into that a little bit, because you might have someone out there saying, it's getting warmer, we're going to have less snow. Obviously, and we're talking about previously in this episode that it was a lot of snow that came down all at once. So how do you reconcile the fact that there may be less snow or higher snow elevation moving forward, but flood events can be more likely at the same time? This idea that the ecosystem is perhaps drying in a way, where you mentioned we may see drier summers, but flooding can also be more likely at the same time. To someone who doesn't study this, that might be contradictory, right?
I think there's two truths there. One is that it's getting warmer. It's getting warmer in all seasons. It's gotten 2.8 degrees, 2.7 degrees Fahrenheit warmer since 1950. By the end of the century, or let me say by the middle of the century, it'll be probably 4 to 6 degrees Fahrenheit warmer, and then it could go in different directions to the end of the century. So it's getting warmer. The other thing that's happening is the season of precipitation is changing, and we've seen that also in the historic record. So if you look at what was like in 1950 compared to now, we get less precipitation in December, January, and February, and we get more in March, April, and May. The season of precipitation has shifted. So winters are drier and springs are wetter. The same is happening with summer. Summers are drier, falls are a little bit wetter. So it's not that the amount of precipitation has changed, and even in the future, the precipitation will increase a little bit, but not very much. It's that the season of precipitation is changing. So think about what that means. It means that you're going to get less snow because it's happening later in the year. The snow is going to melt sooner, maybe as rain on snow events. It's going to come off the mountains sooner, and then we're going to go into summers being drier because we depend on those reservoirs of moisture, and we're not going to have them in the summer. Summers are going to be drier. So when people say we have floods, it's because the snow is melting faster. When people say it's getting drier, it's because we go into summers with less moisture. So in a lot of ways, they're really tightly coupled, but
Right.
they seem a little contrary.
Yeah, and climate change could in effect cause more flooding and more fires, right?
Exactly. It's quite likely that climate change will do that. More spring floods, drier summers, and with drier summers come things like more wildfires.
And one thing in your Greater Yellowstone assessment that you talk about related to flooding is you say that rain on snow events might be more likely compared to the past. And so how do you guys arrive at being able to use that term?
Well, more likely is a probability term, really. And it's because the air masses are warmer, because the temperatures are warmer. And the oceans are warmer, so you're transporting more moisture from these warm oceans because there's more evaporation, and the air masses are warmer. And then when they come to Yellowstone, you're going to see rain. So we'll get some snow because we still have winters and it's still cold in Montana. It can be. But more of the precipitation is going to shift over to the rain side of the equation. And that's the rain on snow.
That leads to the flood.
That
could lead to the flood.
Can lead to
Right.
floods if it happens quickly,
Right. It does take a perfect set of circumstances or the conditions to be right. Maybe not exactly perfect, but as 2022 conditions were definitely right for that. But did you see the aerial videos that were put out by the park? I was kind of wondering where you were during the flood event.
I was kayaking on the Missouri River to the north, and you could see these clouds, to the south, and we were getting kind of worried about, what it was going to mean for our weather, but we were fine. And then as we were driving home from eastern Montana, we got the news that Yellowstone Park was closed. And that's just astonishing. You're like, what? what did they say? Yellowstone Park is closed. And and so that was my first my first understanding of that storm. They didn't close during the fires of 1988. They closed parts of the park, but not completely closed. So, yeah, I couldn't wait to get home and just get online and get on the radio and try to figure out what was going on. And then I saw the videos, which came out later.
Yeah.
And they just kind of curl your toes to see what happened.
What was your initial reaction when you saw, which video did you see first? There were a few different that kind of came out in that time span.
I saw the one the Park Service put out. Is that an amalgamation of various videos?
Did you see the one where the helicopters kind of flying over the road that was washed out? And,
yeah,
that was.
And you're watching banks slough off into the river and so on.
Yeah, as a scientist and just a visitor to Yellowstone, can you kind of take us through your initial reaction to that video? What are you thinking?
Yellowstone always has surprises for me, things that I just don't expect, and then they happen, and it really shapes your whole worldview of how the ecosystem works and what influences it and so on. So I didn't see anything that I haven't seen before. I mean, I've seen videos of floods and things, but these were places I'd been and places I'd camped and places I'd hiked to. So, yeah, it was pretty exciting. And also, I mean, I don't want to make it sound like it was all positive, because you're watching houses wash into the river and bridges getting blown out and landslides and things like that. And it really was so fortunate that no one was, really injured seriously in that event.
And when was the first time you visited the park after the flood? And what did you see it?
Yeah.
Look at any of the damage, and what was your reaction?
I didn't get to the really intensely the areas that were really intensely hit by the flood, because I was just trying to stay away from that part of the park.
Right.
And so my first introduction to that area was that we're doing some research on some lakes there, and we needed to hike down to the Yellowstone River to put in some instrumentation. And that was my first look at how high the floods came up, and really how they wiped out a lot of the backcountry campsites that I was expecting to stay at and so on. And the cabin down there, Blacktail Cabin, where I'd spent quite a bit of time as part of my research work, was gone. Was just gone.
That's crazy.
Yeah.
The flood really changed the landscape to this day. I mean, they've had to reroute the roads. They're, of course, building a new north entrance road, so you'll be able to see the remnants for years to come.
And that's a good thing. People should see that nature's dynamic and unpredictable in some ways.
Right. So this term comes out around the flood, 1 in 500, and it's something that I think a lot of listeners may have heard in relation to the 100-year floods, 1 in 100. And I'm just curious if you can kind of put that number in context for our listeners. What does 1 in 500 mean in relation to this event?
Yeah, originally they were saying the floods were the 1 in 1,000-year event, and then they kind of changed it. So now they say it's a 1 in 500-year event. And that's really kind of misleading, because you get the impression that you'll only get a flood like this every 500 years. Right. And what it's really saying is that the likelihood of a flood of this size or greater is 0.2% probability in any year of a flood being at that magnitude or greater. So 0.2%, it's not insignificant, but it's quite small. And so if you think about it that way, rather than 1 in 500 years or 1 in 1,000 years, then you realize that kind of event can happen any year. Just because we had it in 2022 doesn't mean that, we wouldn't have had it. And I don't think we'll have it in 2024, but in some ways the conditions are similar now.
What do you mean by that? How are they similar, kind of?
Well, we didn't get much snowpack. We were below normal through most of the winter, and then we've gotten these big storms. Not as big as in 2022, but we've gotten a lot of precipitation in April and May, and it's now quite warm. So we're watching it melt pretty rapidly. What we don't have is that warm, slow-moving storm system, that's dumping a lot of rain on the snowpack.
That doesn't mean it couldn't happen, though.
It doesn't mean it couldn't happen, and so we're in kind of a race in time, right? How much will the snow melt before such an event might occur, if it occurs? So the thing in 2022 is that I guess I don't want to say perfect storm, but it came at just the moment when there was a lot of snowpack that was melting, had already started melting really fast. And I don't know if that doesn't happen every year. Obviously, otherwise we wouldn't have a 1 in 500 year flood. The probability would be much higher.
So one of the things people might not realize about this flood event is it actually could be changing peak stream flow for the ecosystem. So one thing to talk about is how shifting peak stream flow can affect Greater Yellowstone.
Yeah, we've seen, when you look at stream gauge data, you can see that streams are having their peak stream flows 8 days earlier than they did in 1950. And that's a function of the more rapid snow melt that we're seeing. So it's, again, as I explained, the warmer temperatures are melting the snow faster, and the snow's coming off the mountains faster. Well, that makes a peak in the stream flow. Because we lose our reservoir of water sooner, then you go into the summer with less stream flow. It comes off, they say it's a flashy system, it comes off in a big way for a short period of time, and then you go into summer with lower stream flow, and lower stream flow is usually warmer streams, and so that's why a lot of our streams have been closed to fishing many summers in a row now.
That kind of segues that a little bit into some of the work you do. So you deal with, you got a book with you, so our listeners won't be able to see, but it's the Greater Yellowstone Climate Assessment. But for those of you that watch on YouTube, on the video, you can see it. And so in that, you're kind of looking at how the climate of Yellowstone was in the past and where it may go in the future. So do you want to kind of put this change we're seeing this year, or some of the differences in the snow occurring later in the year, in context? Like how was it in the past, kind of precipitation patterns in the winter and spring, and now what are you guys predicting for the future in some of your work?
Can I back up and just tell you about the assessment a little bit?
Let's just start with the assessment. That's good.
Okay. Well, let me start with the assessment from a personal point of view. I've published over 200 scientific papers, quite a few of them on Yellowstone. And, as you get farther in your career, you just realize that you're not reaching the public with these papers. So about 10 years ago, I really thought we need to put together a document that explains climate change in a way that everyone can understand, or most people can understand. We need to take this vast amount of literature on climate change and put it into language that's useful and usable, as they say. And that's being done at different levels. It's being done internationally and nationally. We have the National Climate Assessment, but it's not being done locally. And so local people still don't really understand how climate change is going to affect them. So this assessment you can think of as a report written by a couple dozen authors from different backgrounds, trying to explain what we know about climate change in the Greater Yellowstone ecosystem. And so we know a lot of things from that. We have these long-term records, which is what I really study. And, we know that our whole landscape has been shaped by climate change, by large floods in the past have had an enormous effect on how rivers look and how the valleys look, and the steepness of the mountains is due to glaciers and climate change. So we know climate change has just always been important in this region, just like everywhere else in the world. But one thing that we're seeing now is temperatures are rising faster than we've seen for the last 800,000 years for sure, and probably for the last 20,000 years. We're seeing higher temperatures. So, for example, from 1950 to now, the Greater Yellowstone region's gotten about 2.7 degrees Fahrenheit warmer.
Wow.
So it goes up and down, but the trend is very, very clearly getting warmer. Precipitation hasn't fluctuated very much on an annual basis. We've had some years of more snowfall, some years of less, and it kind of goes up and down, and there's not really a trend. But what has changed with precipitation, and we can see this since 1950 and going farther back, is the timing of precipitation in a year has changed. So it used to be that we got most of our precipitation in December, January, February. And now that's shifting so that actually those months have gotten drier with less precipitation. And we get more precipitation in April and May, March, April, and May. So there's a shift in the timing of precipitation. The same way summers have gotten drier and falls have gotten wetter. And that has a huge impact on the whole ecosystem because it determines, as we were talking about, whether you're going to get snow or rain. So if you get precipitation in December, January, February, it's going to come as snow. When you get it in April and May, it's quite likely going to be rain.
And how does that affect the ecosystem?
Well, you have warmer temperatures, you have less snow, more rain. The snow melts sooner and faster, and then you go into summer being drier. So you set yourself up for a situation where even though annual precip isn't changing, you have drier summers. And that sets you up for more fires. It sets you up for just changes in when plants are growing and producing fruit and that sort of thing. It's not a drastic shift, it's a subtle shift, but it changes the way the ecosystem operates.
Do you think that sort of shift makes this type of flooding more likely, or is that impossible?
It makes it more likely because you're melting the snow faster. You're getting more of that wet rain-snow situation. You're increasing the likelihood of a rain-on-snow event. And then as it's melting faster, it's coming off faster, and the likelihood of spring flooding increases. And so we think going into the future, the likelihood of spring floods is going to be higher than it is now, or it has been in recent times.
Do you think there's anything that we can do to plan for that?
Well, in terms of I guess the answer is sure. We can make sure our infrastructure is up to the challenge of more floods in the spring. Our highways, where we build our homes, how resilient our culverts are to big flows of water, all of that. Yeah, we can do that. We can also have more monitoring to maybe better, in the very short term, predict when there's a flood event happening. Right now, our monitoring is really kind of at low elevations in the Greater Yellowstone. We don't have such good measurements for snowpack or stream flow at higher elevations.
Yeah, that's something I've heard people discuss in some of the other interviews we've done for this, is that there wasn't good advance notice of this event because there's not many stream flow gauges up high, and Doppler radar doesn't do a good job of capturing precipitation at that elevation.
I think that's true, that it might have given 24 hours more notice, 36 hours maybe, I don't know. But this was a pretty fast event once it started. I think the bigger question is, are people living in the right places to withstand these kinds of, really high volume floods where streams may leave their channels and do things. So you can say, well, yeah, we could have monitored it and we could have given people 12 hours or 24 hours. I'm sure people would have appreciated that. Right. Everybody would. But I think the bigger question is, are we building things the right way?
Are there any things from your climate assessment that you feel are important to share?
You can't attribute any flood completely to climate change because it's really a kind of a weather phenomenon. But the occurrence of floods is completely predictable with climate change, if that difference makes sense. So when a terrible weather event happens or a big fire, then people say, oh, that's climate change. Well, that's not quite true. But a part of it is due to climate change, and a part of it could be predicted by climate change. And so I think, what we have in the climate assessment very much supports what we saw in 2022. It didn't say when it would happen or where it would happen, but it just said the likelihood of those kinds of events, given the fact that it's warmer and you've shifted the season of precipitation, make these large rain on snow events more likely and spring flooding more likely.
What are some of the other changes that we're seeing in the ecosystem from your assessment?
Well, from a person who studies the past, I can tell you that any time the climate's changed in the past, the ecosystems responded. So, species either have to move as the climate changes or somehow adapt to the changed climate, or they go extinct. And we see that, in the distant past, we see that in the recent past. And I think that's what's happening in Yellowstone now. The climate is changing. It's getting warmer. The season of precipitation is changing. Summers are drier. And things like toads and frogs are having a hard time. Grizzly bears are shifting their ranges as they try to find food. As one food source isn't available, they shift. So their animals are on the move. Birds are coming in before their food sources are available in some places. We're seeing more fires. We thought the 1988 fires in Yellowstone were a really big deal. I mean, they were a big deal. But we've seen way bigger fires almost every year since then, somewhere in the West. So fires and climate change just go hand in hand, warmer temperatures and fire.
You talked a bit earlier about kind of the effect of some of this changing climate on, where people live and kind of us as humans. I was wondering if you could chat a little bit more about how you think it'll affect Yellowstone's kind of vibrant economy, right? A lot of the people that were directly affected by this flood, livelihood is based on tourism revenue to the park. And so I wonder how you might see that changing. Or
we're all going to have to live with uncertainty. And that puts a lot of stress on people. It puts a lot of stress on businesses. We don't know when the next big flood's going to happen or the next big fire, but we're pretty sure it is going to happen. And that stress is just something we have to accept and I guess adapt to. But uncertainty is the name of the game. And I mean, think about less snow, more rain, drier summers. That puts stress on communities looking for reliable sources of water. It puts stress on farmers. It puts stresses on guides taking people down the river to fish. When are the streams going to be closed? When are they going to be open? So uncertainty is one thing we have to deal with. And the other thing that I don't think gets talked about enough with climate change is we're going to have to get used to more people in this area, because more and more people are coming to the Greater Yellowstone area for their holidays and, to visit the park, partly because where they live is just unbearable in the summer.
Right.
So we're seeing visitation going through the roof as more and more people come here. And that puts a lot of burden on our gateway communities and on our backcountry, on our lakes and our rivers. But I think it's a function of climate change too, people coming here.
Yeah, I grew up in Houston, Texas, and now I go home and visit my family, and it's quite hot in the summer.
Oh, yeah,
so
it's awful.
I want to come back up here to Bozeman sometimes as quick as I can in terms of the weather. I love visiting family, but ready to escape the heat.
Yep.
So some climate migration might be playing a factor.
Yeah, and of course, anyone who lives in Bozeman knows that more and more people are moving here because they like the amenities, but also because the climate is nicer than where they're living now. Or where they're coming from, I should say.
So I want to break down something you said earlier. So, flooding has always been a flooding's always been a part of the history of Yellowstone, right? We can see it in some of the historical records. I'd be curious to see if you've seen it in your work at all, how you see it in your work. But then I'm curious after that, kind of what's this term flooding's more likely mean to someone who's not a scientist? Can you break that down a little bit?
Well, I think it goes back to that 1 in 500 year event, right? It's easy to be complacent and think, well, we survived the 1 in 500 year event, so we're pretty much on easy street. But actually, that 0.2% probability can happen in any year. And given the fact that it's the conditions that gave rise to the flood in 2022 aren't going away and are expected to get worse, more intense, I think we're going to see more flooding in the future. But yeah, Yellowstone, a lot of the landscape of Yellowstone's been shaped by floods. So I don't know if that makes anybody living in a gateway town feel any better because we've seen big floods in the past. I don't think so. But, we have seen floods. A lot of the really big floods in Yellowstone happened at the end of the last ice age, around 20,000 to 15,000 years ago, in that time range when the ice was melting and there was a lot of water coming down the river, and there wasn't a lot of vegetation on the landscape because it was cold and, it'd just been deglaciated. And there were a lot of landslides then.
How do you know that from your research? What in the geologic record or some of the work you do tells you when that flooding happened? I think that would be curious to people that don't do this type of work.
Well, I can just give you an example. We're working on a landslide lake in...
Appropriately named.
No, it's actually not. It's called Twin Butte Lake.
Okay.
But it's formed by a landslide when you go there. It's in the geyser basin, and it's up on a mound. And it's a series of little lakes, so we've gotten sediment cores from them. But you say, well, when did that landslide occur? When did that lake form? When we get our sediment cores and we radiocarbon date the organic material at the bottom of the core, it comes out to the end of the last ice age. So, you can imagine a really wet landscape. It's cold. There's no soil. There's no vegetation. That's just the conditions conducive for unstable slopes. And so, in addition to landslides, it's probably quite likely that water, because there wasn't soil for infiltration, just led to big landslides. And you look in most of Yellowstone's rivers, there's huge boulders, round boulders. They've had to have been carried by water. When did they get there? Some of them are as big as a car. Well, they're probably transported by big floods during the melting of the glaciers.
I was going to ask, what lessons do you think people should take from the Yellowstone floods?
That nature is full of surprises. And I think anyone that lived through that flood was surprised.
Yeah.
And it will continue to surprise us. And that the likelihood of these big events is just going to get higher increase because, as I said, the conditions for that kind of a flood are going to be more likely.
Is there anything else you kind of wanted to discuss surrounding the flood?
Yeah, I want to say that Yellowstone, like the rest of the planet, is experiencing climate change. We've seen climate change in the past. We've seen some of these big events, but the rise in temperatures that we're seeing now haven't happened in the last 20,000 years and probably way back. When we look at the levels of carbon dioxide in the atmosphere that we see around the globe, we haven't seen levels this high for over 3 million years. So we are moving into uncharted space in terms of climate. You have to go way back in the geologic record to find anything that you can compare it to. And I'm very sensitive to that because I study the past. And I've always thought the past was the key to the present. But I think we're sort of moving into space now where the past helps you understand the present, but it's not a predictor completely. So people need to realize that These kind of extreme weather events are part of climate change. The warmer temperatures, the changes in snowpack are all very understandable in light of our understanding of how the climate system works. And Yellowstone is so important for explaining this, right? Because it's the last large intact ecosystem on the planet in the temperate latitudes. There's nothing bigger than Yellowstone in the temperate latitudes, the mid-latitudes. And so we need to use Yellowstone as a platform for helping people understand climate change and what it means for ecosystems and the communities that depend on ecosystems being healthy.
So as someone who studies all this, what keeps you up at night concerning climate change and the greater Yellowstone ecosystem?
I don't know if we have the will to take the steps to mitigate greenhouse gases in the atmosphere. I just don't know if society's going to respond fast enough and take the actions that are necessary to sort of right the climate system. So that depresses me and worries me. And I worry about my granddaughter. I wonder what her world's going to be like. I'm going to see warming for the rest of my life if I live to the mid-century. No matter what I do and who I talk to and who I convince, it's just going to get warmer. But her life is really sensitive to what we do now, and the actions we take now will influence what she sees for the rest of the century, whether we warm a lot or we flatten the curve. That's completely in our hands now. So I worry about her, and I worry about, is she even going to recognize the places that I know and love in Yellowstone when she's old enough to go off on her own and explore them?
What are some of the changes that could happen that would make it unrecognizable to her?
Well, we're going to have fires, more fires, I'm sure. We're going to have more flooding, spring flooding. We're going to have drier summers conditions, so that's going to affect the vegetation. The snowpack is going to be completely different. There'll be much less snow. You can see climate projections showing the snowpack just going sort of to higher and higher elevations through the coming century until it finally leaves our peaks completely. So she's going to notice all those things, and all those things will impact the ecosystem.
Can you give some examples of that? I'm just curious.
Well, it'll impact the vegetation. The wetter forests that we have will eventually be converted to drier forests, and the drier forests will be converted to shrubs, more grassland, as we continue to burn it. The diversity of amphibians is probably going to decline a lot. The animals, the top predators that we go to see are going to, I don't know where their range is going to be and what their interactions with people is going to be when they leave the park, but they won't find the food they need, I don't think. It'll change the way the mating season of animals and the rut, and it'll have noticeable changes in the way the ecosystem functions.
As we wrap up here, I wanted to ask you, what is your hope for the future of Yellowstone after the June 2022 flood event?
A lot of what I hope I know is already happening, and that is people are really taking a serious look at the infrastructure of the park to make sure that we're going to be ready for these kinds of floods in the future, that our roads are in better shape. A lot of these roads were built, decades ago in the absence of such flooding, and that our buildings are properly located and our water treatment systems are better able to handle these kinds of events. And I think that's happening because that's just common sense. And it's common sense because it's being done in the realization that these events are going to happen again in the future. So I'm hopeful about that, and I'm glad to see that. And I think that anything that happens in Yellowstone is a learning opportunity. And so I hope that when people drive through the park and are looking at the effects of these floods, they're better learning about how systems respond to climate change and what some of the climate surprises are that we can expect to see.
All right, well, I think that's a good place to end it today. Dr. Whitlock, thank you so much for joining us on the Bison Jam podcast. If you'd like to learn more about Dr. Whitlock's work, please visit gyclimate.org to learn more about the past, present, and future of climate change in the Greater Yellowstone ecosystem. And for our listeners, be sure to follow along as we continue to explore stories of the June 2022 flood event in future episodes. Thanks so much for listening, everyone, and we'll catch you in the next episode. Bison Jam is a production of Hugo Sindelar Media, LLC. I'm the director and producer, and Ashley LeBow is our editor and story consultant. This episode was filmed by Braden Meyer, and our guest was Dr. Cathy Whitlock. Additional support for this podcast comes from Montana State University. Be sure to listen to future episodes wherever you find your favorite podcasts. We'll see you soon.